Complete combustion of propane can be represented by the equation CH3CH2CH3 plus 5O2 produces 3CO2 plus 4H2O. Calculate the enthalpy for the combustion reaction. So the first thing we need to do is figure out what bonds are broken and what bonds are formed. So let's start with the reactants and figure out what bonds are broken. The reactant side, we have carbon bonded to hydrogen. So we have carbon bonded to 3 hydrogens, then 2 hydrogens, then 3 hydrogens, for a total of 8 carbon-hydrogen bonds that are broken. And then we have 5 oxygen-oxygen double bonds. Oh, and I forgot also, we have these carbon-carbon single bonds here and here. So 2 carbon-carbon single bonds. So these are broken. And then on the other side of the reaction are the bonds that are formed. So carbon dioxide, I'll just draw the structure down here in the corner to remind you. And I'm just going to draw the bonds. I'm not going to draw the lone pairs since that's what we're focusing on. But each carbon dioxide molecule has 2 carbon-oxygen double bonds. And then we have a coefficient of 3, so that's a total of 6 carbon-oxygen double bonds that are formed. And then, of course, our water molecule, each molecule is 2 oxygen-hydrogen bonds. And we have a coefficient of 4, so that's 8 oxygen-hydrogen single bonds that are formed. So now we just need to use our equation to calculate the delta H for the reaction. So delta H for the reaction is the sum of the bond energies for the reactants minus the bond energies for the products. The reactants, we have these carbon-hydrogen single bonds, so that value is right here. We have carbon-carbon single bonds right here, and oxygen-oxygen double bond, which is right here. Okay, so 8 times carbon-hydrogen single bond is 413 plus 5 times 495 plus 2 times 348. Okay, so this is our reactants. So it's all of this minus the delta H for our products. Carbon-oxygen double bond, which is right here, 799. And oxygen-hydrogen single bond right here, 463. 6 times the carbon-oxygen double bond is 799 plus 8 times 495. All right, if I put in all the values on the left for the reactants that I see in purple, I get 6,475 minus, and then if I put everything in on the right for the products, I get 8,754. So if I find the difference there, 6,475 minus 8,754, I get a delta H for my reaction equal to 2,279 kilojoules. All right, so when solving these problems in the future, you just have to determine the number of bonds that are broken, multiply that by the bond enthalpies for the bond that's broken, and find the number of bonds that are formed, multiply that by the bond enthalpy for the bond that's being formed, and find the difference between the bonds broken minus the bonds that are formed.